Hey guys! Today we're going to go over problem 6.3 from the book. In this problem, we need to find the force in each member of the truss and then state whether or not they're in tension or compression. I'm going to solve this problem by using the method of joints, and I'm going to start at point A because we have one known force which is given, 130 pounds, and then two unknowns. So it's a good place to start when you're working on a truss problem. Once we've chosen our point, we can make a free body diagram at A, and then use our equations of equilibrium to find out what all of our internal forces are. Now, for the sum of the forces in the y direction, we can set it equal to 0, and we know that 0 equals 4/5 of FAC, and we know it's 4/5 because it is in the y direction, right? And then we can use the 3, 4, 5 triangle we have, and then to just solve for the y direction. So it's 4/5 FAC minus 12/13 times 130 pounds, which we can get the 12/13 because since we already have this in the given information, and we'll have a y here, it is equal to 12/13 times the force, 130 pounds. When we simplify this, FAC is equal to 150 pounds, and because it is positive and we already drew it in compression, right? FAC is in compression to point A, then we know it is still in compression. When we move on to the sum of the forces in the x direction, then we can get 0 equals to FAB minus 3/5 times FAC. Notice how that's different than when we do it in the y direction. Because of our 3, 4, 5 triangle, we can I'll do this in a different color. If it's like this is the x direction of FAC, then it's the 3/5 of FAC. Minus 5/13, right? This is in the x direction, like here. 5/13 times 130 pounds. Then this will give us FAB is equal to 140 pounds. Now, since we drew this in tension and the answer is still positive, we know we drew it correctly and the force is in tension. We can move on to the next point, which we can choose B since we know what FAB is, so that we just have two unknowns left, the same way why we chose A, by the same logic. And so then the sum of the forces in the y direction will show us that FBC just equals to 0. This is a 0 force member, which can be shown because we have two collinear forces and then this FBC. If you want to know more about zero force members, you can refer to the book or lectures. Then the sum of the forces in the x direction are also equal to 0, which you can find that FBD is equal to FAB, which we've already found is 140 pounds. And since drawn in tension and it is positive, it is still in tension. Moving on to point C. If you do the sum of the forces in the y direction here, then we'll get an FCD equal to 150 pounds. And if we do the sum of the forces in the x direction, we'll find that FCE is equal to 180 pounds in compression. Then we can move on to point D as we start eliminating more forces and moving on to the next points. Where here like I said before, we have the FBD and FCD, so then we just have two unknowns to solve for. If we take the sum of the forces in the y direction, again, we'll find that FDE is equal to 120 pounds. And as it's drawn in compression and it is still a positive value, it'll still be in compression. Then, if we take the sum of the forces in the x direction, we'll find that FDF is equal to 230 pounds in tension. Lastly, if we look at point E and we take the sum of the forces in the y direction, we'll find that FEF is equal to 300 pounds and compression.